Hello everyone. Today let us discuss about numerical problems of the capacitors. That is, capacitors can be connected in series, capacitors can be connected in parallel. So depending upon the different circuits, we get different problems. So main thing is we should know the formula related to the series combination and parallel combination. The series combination and parallel combination of capacitors are connected. We have to find the resultant of them. And sometimes they connect them in different ways, and they also ask us to find the energy stored in the capacitor or energy stored in the combination of the capacitor. So for that we should know some formulae. So let us see what are the required formulae. So let's take for example the first formulae, which is a series combination, that is 1 by Cs is equal to 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus etc. etc. This is for series combination. Next we have for the parallel combination Cp is equal to C1 plus C2 plus C3 plus etc. etc. This is for parallel combination. All these derivations I have derived in my previous videos. You can go through them and you will see them. Okay. So after that we need some more formula. What are the some more formula? That is the fundamental formula, like very basic formula of the capacitor. You all know Q is equal to CV. So that gives C is equal to Q by V. So this formula, this is another formula which you should know. This we already know from the beginning. And another things like what we need to know is energy stored in the capacitor, that is U is equal to half CV square, that is equal to half Q square by C, that is also equal to half QV, half QV. So these are the main formulae which we will use in this numericals. And sometimes you may also know, you may also have to know this energy density or energy stored per unit volume, that is small u is equal to half epsilon naught E square, where epsilon naught is the permittivity and E is the electric field. So another formula which you have to know in case of some other numericals, that is electric field between the capacitor plates, E is equal to sigma by epsilon naught, where sigma is the surface charge density and you know E is the electric field and epsilon naught is the permittivity of the free space. Now coming to our problems, we will solve them, but before going to solve them, always I tell you one thing: you have to by heart this formulas. That is, all the formulae you should learn by heart. If you are unable to remember them, please write them, each one of them. Please write each one of them five times. Every formula you write five times. Then easily you will remember. If you cannot remember even after writing them, what you can do is you open the book again, learn them, close the book again, write five times. By the end, by the end of the time, you write them 10 times, definitely you will remember the formula. So don't be afraid, don't be scared to do the numericals. Most of the children are very much scared to do the numericals. Nothing is difficult with the numericals. Only thing is you should know little part of the theory, and also you should know the correct appropriate formula for the related problem. So now here we have taken this particular one. This is the first circuit which we have taken for today's discussion. We can do so many numericals, but in YouTube we don't have much time. So I have taken only 3 problems, 2 related with the combination, 1 related with the energy I have taken. They have given a circuit like this and they asked Find the equivalent capacitance of the combination of capacitors between the points A and B as shown in the following figure. Also calculate the total charge. Also calculate the total charge that flows in the circuit when a 100-volt battery is connected between the points A and B. So let us analyze the circuit and let us go slowly and try to understand. Our circuit is our circuit is like this. So we have a point A, here we have a capacitor, and then here again we have a capacitor, and then in between them there is a junction like thing. From there one line is taken, here two capacitors are connected in series, and this comes like this, and here there is another capacitor, here there is another capacitor, and this is B. So this is 40 microfarads, 60 microfarads, 10 microfarads, and 10 microfarads, and this is 60 microfarads, and this is 60 microfarads. So now we have to solve this problem. So what we will do is slowly we will try to understand. You can see here. First thing is the first thing is very first thing which you can see, which I am marking with this red color line. These three, that is 1, 2, 3, they are in series. When they are in series, let us find the resultant of three of them, that is 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3, that is 1 by 60 microfarads plus 1 by 60 microfarads plus 1 by 60 microfarads. This is the formula which I am using here. So this is the formula which I am using here. This is the one. So this one I am using there. Then after that, let's simplify that calculation. That is you can take LCM as a 60. 1 plus 1 plus 1 plus 1 plus 1 1 plus 1 plus 1, that is 3 by 60, that is 1 by 20. So the resultant of these three, let us keep one subscript for that. Let us say it is C1. Then C1 is equal to reciprocal of that, which is 20 microfarads. Now if you see the circuit, this 20, and then this 10, this 10, wait a minute, I'll put a mark for that, the yellow color 10 here, and another one, the blue color 10, and this combination of three, they all will become a parallel combination. I will redraw the circuit for simplicity. I will redraw this. You will get like this. This is A, the point A. Here we have 40 microfarads, and then it comes like this. From here 10, again 10, and these three together they made a resultant of 20. So this is the point B. So now it becomes 10 microfarads, 10 microfarads, and 20 microfarads. Now three of them will become parallel. Let us take something for that. Let us assume that is the resultant is something C2. Let us say that is C2 is equal to C1 plus C2 plus C3, that is equal to 10 plus 10 plus 20, that is 40 microfarads. So these three together, which I am marking with the blue color, they make a parallel combination 10 plus 10 plus 20, which is 40 microfarads. And then that 40 microfarads will come again in series with this 40 microfarads, which I am showing with the arrow mark. So finally what we will get now is the resultant is once again that is a series combination of the 40, which is I have shown with the arrow mark here, and the resultant of these 40 and 40 they will become in 40 and 40 they will become in parallel. Therefore let's continue. Let us take that is let us give one name for that. The initial one, let us take it as something like C3. Then C3 and C2 will come in series, therefore in series combination. Therefore the resultant is C is equal to that is C3 in series with C2 in series with C2. So that is 40 and 40 are in series. So that means 1 by 40 into 1 by 40 plus 1 by 40 is, we can make a shortcut method, that is 40 into 40 by 40 plus 40. That is like when two capacitors are in series, you can use the formula C1 C2 by C1 plus C2. Then that is nothing but to keep 40 into 40 like that only, because calculations will be simple. Don't multiply it, and 80 you will get. Then it becomes 2 times, and then 2 cuts it 20, that is equal to 20 microfarads. So finally the resultant is 20 microfarads of the combination. Then with that the question is not over. They also asked us if it is connected to a potential difference of that is a battery V is equal to 100 volts, find the charge which is flowing. Find the charge which is flowing. So that is what they asked us. Then we have a simple formula which we know Q is equal to CV. Then C is 20 microfarads 10 to the power of minus 6, and V is 100. Finally it will become 20 into 10 to the power of minus 4, or 2 into 10 to the power of minus 3, that is coulombs, that you can also write as 2 millicoulombs. 2 millicoulombs. This is the answer for that question. This is the answer for that question. So the first question is over. First question is over. Now let's proceed to the second one. Let us proceed to the second problem. These problems are frequently asked in the board examination, as I have observed them earlier also in the old question papers. So like this they will give one circuit. This is the second problem I am taking now. This is the second problem. Now let me mark it like it with yellow color. Yes, I have taken as yellow color. Yes, please, just a minute. Now you can see it. This is the circuit which we got here now, and they have given 4 capacitors. 1 minute, another line is also there. That line is between this point and B. Yes, that is also there. So now for this you have to find the resultant capacitance between the points X and Y. Many children looking at the circuit, they get confused. Nothing to be confused with that. Only thing is you have to redraw the circuit. So let us see, this is X, and then first we have 4 capacitors like this. You draw them like this, and put Y. You can do on your own. This is the point A, and after the here we have the point B. Then the first one is 2 microfarads, second is 3 microfarads, third is 5 microfarads, and the last one is 10 microfarads. Then after the first one there is a junction, after the second one also there is a junction. From A the point comes and joins here. Similarly, from after this one that has joined to B. So what I tell you is redraw the circuit in a simple way. Just put two dots A and B. Put some names for this capacitor C1, C2, C3, C4 you can take. You can take like that, and then now if you can see, now what happens is one plate of C1 is connected to the junction A. So take C1 here, put these points as A and B. One plate of C1, it is connected to the junction A. Look at this second one, that is second plate of C2. It is connected to this point. This point has gone to the point B. Yes or no? Therefore, now you can do one thing. The other plate of C1 you can connect to B. It is a simple method. Now, next select the second one, that is the C2 capacitor. Look at that one. Left plate of C1 is connected to one point. That is, I will redraw here. Left plate is connected to this junction, but that point is nothing but it is connected to the point B. Yes or no? Now, what you do is one plate of C2, that is you can connect to C2, connect to the point B. Another plate of C2 is connected to this point. This point comes here like this, again connected to A. So therefore C2, one plate is connected to A, another plate is connected to B. So that is also connected. Now just for your convenience, for your understanding, I am drawing the lines. Let's take now the third capacitor C3. See here, C3, one plate is connected here to this point. This point has gone like this and connected to A. Another point of C3 is connected directly to B. So you can write like this. This is C3. One point is connected to A, another is connected to B. Now what happened? It is a parallel combination of C1, C2, C3. Yes or no? It's a parallel combination of C1, C2, C3. Then it's very simple for you to calculate now. Nothing but one is that is C1 is 2 microfarads. Yes, C1 is 2 microfarads. C2 is 3 microfarads. Yes, and C3 is 5 microfarads. Therefore, all this combination, it is further extended, connected to another 10 microfarad capacitor, that is in series. And this side last we have X. Now 3 of them are in parallel. Therefore, you will get 3 of them are in parallel. Therefore, you will get the combination of C parallel is equal to C1 plus C2 plus C3, that is 2 plus 3 plus 5, which is 10 microfarads. The combination is 10 microfarads, that is connected again here to another 10 microfarads, which is I am showing with the arrow mark. Then both of them come in parallel. As I told you, C resultant I am taking. As I told you, let us put a name for that as C4. Now that Cp and C4 will come in parallel. When two capacitors are in parallel, I told you the formula, that is C1 C2 by C1 plus C2, general formula. But in this case now, we are taking as a Cp and C4, Cp and C4. Therefore, we get Cp into C4 by Cp plus C4, that is 10 into 10 by 10 plus 10, that is 10 into 10, don't multiply anytime, 20 you take, then 10 twos and then 2 fives. So the resultant is equal to 5 microfarads. The resultant is equal to 5 microfarads. This is the second problem which we have solved now. Then after that, without wasting much time, let's see the third problem. The third problem, yes, let's see, this is the third problem. I'm marking with the pink color. See, two identical capacitors of 12 picofarads each are connected in series across a battery of 50 volts. How much electrostatic energy is stored in the combination? If these were connected in parallel across the same battery, how much energy will be stored in the combination now? Then after that, last one more point question, also find the charge drawn from the battery in each case. For that, what we have to do, we have to use the energy related formula. So this is the energy related formulas. These are the energy related formulas. So looking at that particular problem, out of these three formulas, three are energy only, you can use anything of your choice. So you can use anything of your choice depending upon the values. So let's start our problem now. Let's start. This is the energy problem. So let's go and start the third problem. This is the third problem. Now here two identical capacitors 12 picofarads are connected in series. So let us draw the circuit like this. This is 12 picofarads and this is also 12 picofarads. They are connected in series. Okay, we connected them and across a battery of 50 volts. That means here there is a battery which is 50 volts. Then battery has a big line positive, small line negative, and you all know that. What is the electrostatic energy? First let us find the resultant of these two capacitors. Because they are in series, let it be C1, let it be C2. The resultant CS is equal to C1 C2 by C1 plus C2, that is 12 into 12 by 12 plus 12, that is, don't multiply 12 into 12 by 24, 12 twos and 2, that is 6, and you will get resultant is 6 picofarads. Now you have the value of C and you have the value of V which is given. So which formula is suitable for energy? So you, out of these three formulas, because you know the value of C and you also know the value of V, this particular formula which I am marking with red circle, that can be useful, half CV square. So let us use it and calculate the energy. Calculate the energy, that is, we got 6 picofarads and the battery is 50 volts. This is 6 picofarads. Then let's write the formula. Energy formula, half CV square, that means half CS V square, that is half C means 6 picofarads, 6 into 10 to the power of minus 12, V means 50 square, that is half into 6 into 10 to the power of minus 12 into 50 into 50. And once you simplify it, I am not doing every calculation because in YouTube it will take quite a long time. then after simplifying you will get 75 into 10 to the power of minus 10 joules. This is the energy stored, this is the energy stored in this particular system of series combination. But what they have asked in the question, in each case, they also asked us to find the charge drawn from the battery. So you can see this is what they have given. Also find the charge drawn from the battery in each case. We found the resultant capacitance, we found the energy. Now we have to find the charge. For that, this fundamental formula will work, that is Q is equal to CV. This formula we can use. Third formula, Q is equal to CV. From there we can find the charge. Then let's go and calculate the charge. That is Q is equal to CV. In this case, this is Q. Let's write this is a series combination. So QS is equal to CSV. That is QS is equal to CS is 6 picofarads, 10 to the power of minus 12. Voltage is 50 volts. Then you will get 300 into 10 to the power of minus 12, or 3 into 10 to the power of minus 10 coulombs. This is the charge that is drawn in the series combination. This is the charge drawn in the series combination. So this problem is not over. They also asked us to find the same thing for the parallel combination. So for the parallel combination, it is simple because parallel combination formula is quite simple. That is CP is equal to C1 plus C2. So parallel combination comes like this. Two capacitors are connected in parallel. Then this is given to a positive terminal and this is given to a negative terminal. Just 1 minute. Yes, this is C1, this is C2, this is 50 volts with plus and minus. This is 12 picofarads, this is 12 picofarads. Then CP is equal to C1 plus C2. Simple it is. 12 plus 12, which is 24 picofarads. This is CP. Then energy UP is equal to half CPV square. That is half into 24 into 10 to the power of minus 12 into 50 square. Then it becomes half into 24 into 10 to the power of minus 12 into 50 into 50. Then once you simplify, you will get UP, that is energy stored in the parallel combination, 3 into 10 to the power of minus 8 joules. 3 into 10 to the power of minus 8 joules. And another thing is charge stored in this, charge drawn in this combination, that is QP is equal to CPV. Q is equal to CV, which we also used for series combination, which is in this pink color. Similarly, we will write QS is equal to CSV, we used here, which I am marking with the red color. Similarly, QP is equal to CPV, we will write here, and then we will get now, that is CP parallel combination. We got this is 24 picofarads and V is 50. Therefore, let us write 24 into 10 to the power of minus 12 into 50 that is equal to 1.2 into 10 to the power of minus 9 coulombs. This is the charge. Charge is stored in the parallel combination. So this is the answer. This is the answer for this uh, third question in both the things. This is the energy. This is the energy which I am marking with this pink color. This is the energy stored in parallel combination, and with this the pink color inside red is there. That is nothing but this is nothing but that is charge drawn by the parallel combination. So in this way you can solve the problems. Now I have solved three problems here. Three problems here. We can solve as many as possible because once you know the formula, it is easy to solve them. So I'm selecting a few problems because if we explain more problems, it will take quite a long time. So I'm taking few problems. If you have any doubts, you can send a message, contact me. I will help you out to solve many more problems. We'll meet in the next video with some more problems and some more theory points also. Till then, bye. God bless you all.